Hey everybody, Mr. Bells here. I want to go through some stuff with sequences and series and how to use that on your calculator besides just the formula. So this is technology-based sequences and series. So the first thing that I want you to be able to know is that we have two different types of sequences. Say that we have 10, and then we have 17, and then we have 24. And then we have 31, and you can see that on each one of these cases, these are going up by 7 each time. Well, that means that this is an arithmetic sequence. And I could generate that sequence a couple different ways on my calculator. And I'm going to show it to you on both of these calculators right here. So this is your this is your newer version for it. And if I go to second and to stat, and I have these two commands here, names, which is just all your lists, ops, there's sorting, descending, ascending, dimensions, fill, sequence. Oh, so sequence. So number 5, I'm going to choose sequence. When we have it in here, the first thing we have to do is we have to write an expression or an explicit formula for the sequence. And I believe we probably talked about explicit formulas already. So I'm going to go ahead and write it for this one here. So in this case, an explicit formula for an arithmetic sequence takes the difference, which is 7, times a variable n or x or j or q or whatever you want it to do, and then plus, and whatever this is a sub 0. So it's the term that comes right before the first term. If this is a1 and this is a2 and this is a3. Okay? So in this case, if I'm going up by 7 here, and to go backwards, I go down by 7. So this must be 7n plus 3. Okay? So that is what gets stored right here. Now, I already used x in this case for whatever was in there before, so I'm going to go ahead and use x again. So I put the expression or the explicit formula in here. I put in the variable x. I choose where I started at, which of course would be the first term, and where I ended at. And I could end it at any of them. So if this says 1 to 50 with a step of 1, that means it's going to do term 1, term 2, term 3, term 4, term 5, all the way up through the 50th term. And I go here to paste, and I hit enter. And you can see 10, 17, 24, 31, 38. That's the exact same pattern that I had going on right here, except that gives me that sequence all the way out. Now, if I wanted to add all of these things all the way up through, say, the first 100 terms, a to 100, then I could just go ahead, oops, sorry about that. I just could go ahead and I could sum that sequence. Now, summing on your calculator, you can do two different ways. So you can go over here to math, and you can go down here to sum, and then you can choose the sequence that you had from above, or you can just rewrite it again. So I'm just going to do it again from here. So again, that second stat over to ops. I'm going to generate that sequence, and I said I wanted to sum the first 100, so I just simply type in 100 right there. I hit enter, and again, stepping by 1 means it's going to go up by 1. So first term, second term, third term. If I was to step it by 0.5, that would be like doing 0.5, then 1, then 1.5, then 2, then 2.5, then 3, which isn't really a sequence, but it is something that's very useful in some other mathematical applications, and that's why it's in there right now. So I go ahead and go to paste, and now it's summing the sequence, and it tells me that the sum of that sequence is 35,650. Now, we'll know in class that we also have some arithmetic formulas that we can use to be able to get that same sum using some different stuff. But this video is about how to use it on your calculator. Now, the other thing that you're going to see is this. There's a symbol in sequences and series called a sigma. And a sigma is used as a summation. So if I was to say this, x equals 1 to 10 of 3x squared plus 2, what this means is I'm going to sum up all the values of terms 1 through term 10 that are given by this expression. So for instance, if I plug 1 in, 1 squared is 1 times 3 is 3 plus 2 is 5. So my first term would be 5. And then I plug a 2 in, because I'm going up. All of these are always going up by 1s when we use this sigma thing. So I plug a 2 in, 2 squared is 4, times 3 is 12, plus 2 is 14. And I would keep going up with this all the way up through the 10th term. So, sorry, let's make that h look a little bit better. All the way up through the 10th term. Now, I could do this on my calculator this way. Second stat, and I could go over here to sum number 5, right? I can go here, second stat, ops, sequence number 5, and I could create that little formula right there, which is 3x squared plus 2. Now, I'm hoping you know that 3x squared plus 2 is not an arithmetic sequence. So we don't have a special formula for things that are quadratic. But this system will work. So 1 through 10, step 1, paste, poof. And it tells me that the sum of all 10 of those terms, if I was to write them all out, remember I only wrote the first 2, but the sum of all 10 of those is 1,175. Now, on the newer calculators, they have that actual sigma button, and that's found under the math key. So you can go ahead and hit math, and then scroll down, and it says right there at 0, summation. So I'm going to go to summation, I'm going to hit enter, and it even gives me the whole symbolism here. So I'm going to go x equals 1, I go up arrow, I choose 10, I go to the right, and I put in the expression or the equation that it's going to generate this sequence. 3x squared plus 2, 3x squared plus 2. And then I hit enter, and you can see that that also gives me 1,175. So if you have one of these newer calculators, this summation button is amazing. It's really helpful in terms of these things. Now again, remember, if it was an arithmetic sequence, we actually have a formula that we can use to be able to sum that up. This is not arithmetic. It doesn't go up by the same amount. In fact, I can show you right here. Let's go ahead and do the third term. So 3 squared is 9 times 3 is 27 plus 2 is 29. You can see that the first 2 terms go up by 9, but the next 2 terms go up by 15. And that's not arithmetic. That doesn't go up by the same amount each time. Okay? You can also tell it's not geometric, and we'll talk about that later if you haven't seen that yet. And that would be division. So 14 divided by 5 and 29 divided by 14 are not the same things, so that's not going up through multiplication. Okay? So either way, using that, that's great. Now, some of you have been frustrated for the last little bit because you have one of these calculators, and that's okay. I said that we would talk about this. So the same thing happens again. I go second stat, and I go over here to ops and to math, and I'm going to do sum. So when I do that, 5, sum, that whole listing stuff doesn't come down, unfortunately. Second stat, over to ops, sequence. You've got to type it in. You've got to tell it what it is. So the first thing following this parentheses is the actual expression. So I'm going to do this one, 3x squared plus 2. And then in order to get the next thing, I need to use the comma. So after the expression, then you have to put the variable that you chose to use in the expression. So that's going to be an x. And then comma. And then next thing is, where do you start your term at? I'm going to start it at 1, comma. Where am I going to end this at? Well, this one said to do it by tens, so 1 through 10, so I'm going to do 10, comma. Now this next thing is an option for you where the other one had the thing step, right? So step, let's show it to you again here. Second stat, over to sequence, number 5, where it says step, that's the last thing. So far you can see 3x squared plus 2, 3x squared plus 2, x, 1, 1, 10, 10, step, 1. So then I put a parentheses. And you can see when I've done it on this calculator right here, and I come down here to paste, you can see that this looks the same as this, except for the fact that I didn't hit sum beforehand on this one. Okay? But This just has a nice menu to sort it all out one at a time. This you have to do here. So I'm going to go ahead and hit, so they're just the same. I'm going to insert a sum in this. So second insert, second stat, ops, math, 5 sum. So now you can see they're identical. Awesome. So I'm going to go to the end of this and hit enter, and you can see it's 1175. And then on the old calculator, I hit enter, and you can see that it says 1175. So those are both nice ways to be able to do stuff on your calculators. Okay, now, if I go over to here on this old calculator under the math key, and I scroll down and I look for that summation thing, you can see that it's not there. So unfortunately, if you have the TI-83 Plus, you cannot get this little symbol right here. It's not located any place in it, or at least no place in it that I know of. So I'm hoping this is helpful for you. I'm going to show you again one more time with one of these things. Let's do it with a geometric one. So let's go 8, 16, that's not geometric, 8, 16, 32, 64, and let's go out here to the 15th term. So we want to do S sub 15 of this geometric sequence. So here's first term, second term, third term, fourth term, fifth term, sixth, seventh, all the way up, dot, 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 through the 15th term. So again, as with anything, if I'm going to use this sum sequence situation, I have to first know the expression that generates this. So that's something that we go through again in class. We talk about how it works out. And hopefully you remember that a sub n equals a sub 1 times our situation is our rate, which is 2, because it doubled each time. You can see it's multiplied by 2 each time, to the n minus 1 power. So we'll check it. We'll plug the number 1 into here. 1 minus 1 is 0, 2 to the 0 is 1, 1 times 8 is 8, and that gets you our first term. So this is the formula we'd have to use. So I would put in here 8 parentheses 2 raised to the parentheses n minus 1, close parentheses, comma. Now if I used n here, I'd want to use n here. So I'm going to go ahead and change it to x for our calculator, because our calculator already has the x button. X, comma, 1, comma, we said 15, comma, 1. And that's what it would look like. So here we go. On this calculator, second stat over to sum, number 5, second stat over to ops, number 5. My formula that works for it, 8, sorry, there we go. If I don't move for a while, again, the lights go off. Parentheses 2, parentheses, raised to the, now on these older calculators, or even on this newer calculator, sometimes it'll do the caret key, and you have to put parentheses to make sure the entire thing's up in the exponent spot. So x minus 1, close parentheses, x1 to 15, up by 1, paste. Looks just like that. And if I add up all those terms, it adds up to 262,136. Showing it to you again using the summation notation. Math summation, x equals 1 to 15 of the expression, 8 parentheses, 2 close parentheses, raised to the. Now here it's a little weirder. In this one, this calculator actually puts it upstairs. Okay, so then I don't need parentheses, but I'm going to use parentheses so that I stay consistent for whoever's out there watching this video. Go down arrow so that I have it just like that. I hit enter and you can see I get the exact same amount. Now, one more time, if I come over to the older calculators that doesn't put it in that way, second stat, I go over to math, I'm going to do sum. Second stat, I'm going to go over to ops, I'm going to do sequence. This is my expression, 8 parentheses, 2 parentheses, and this, you gotta be good with your parentheses in this class and with these calculators. raised to the, remember, parentheses, x minus 1, close parentheses, comma, x, comma, 1, comma, 15, comma, 1, close parentheses, enter. 262,136, 262,136. All of them work out. I hope that was really beneficial for you in terms of how to use a calculator for sums and sequences on a TI-83, TI-84. We'll talk to you later.